And for our ATUR friends joining, this may be some information you've already heard in the past, but I'll go ahead and share my screen. And am I in full screen mode for people? Okay, great. I'm seeing nodding heads.
Yep.
Yeah. So I'm calling this a teaser presentation, but it's representing a large team and a large project. So I'll step quickly through some slides to just kind of give the bigger picture and to also really give credit to our team members. So apologies if I skip over something while you're in the middle of reading it or have additional questions. I'm happy to revisit things at the end or answer any follow-up questions. Before I dive into the project description, we always like to give an homage to Dr. Tom Meixner, who we lost on campus a couple years ago, very tragically. And he was the original PI of this project. He was really the person who generated this project in response to a request from ATUR about how to enhance recharge across the state. So the core team and the approach is really a testament to Tom and the way that he approached these really applied management-driven questions. And it's the 3 state universities working together, which has been really great to kind of assemble all of this water knowledge across the state and really be in service of our water managers and our communities and thinking about how can we be helpful. So there's going to be some slides that have a lot of text on them, and I apologize for that in advance. The broader project goals are, in summary, where and when can we capture water that would have otherwise been lost to the atmosphere? So via evaporation, evapotranspiration, snow sublimation, really being mindful of the policies and regulations that people need to navigate to do these projects. So focusing on supplies that would not reach a natural channel, thinking about both human and wildlife or ecosystem needs, and really thinking about what kinds of practices can we use to enhance water capture or recharge, and how can we think about prioritizing a system for this. So kind of a similar theme for today's presentations. We have 4 project sub-teams that I'll introduce very briefly, and then I'll focus a little bit more on some of the work on the urban team. And we have a session at the Water Resources Research Center's annual conference next week. So trying to keep it high level so that if you're interested, you can really hear from our students and our postdocs themselves. So the first sub-team is a hydroclimate sub-team, which is really focused on the fluxes, say from the atmosphere down to the ground surface, really thinking about how can we, develop statewide estimates of these fluxes, and so that can be a foundation for what are we considering evaporative or atmospheric losses. Also an opportunity to evaluate how climate change can influence these fluxes and integrating the results of this work into other portions of this project. And there are multiple team members here that ideally you will get to hear from directly. This is just an example of a schematic for one of the land surface models that we're using that can really estimate a range of fluxes that we hope can be useful for water managers and people working on this across the state. Our recharge team is really focused on that suitability component. So where and how can we increase recharge potential? Where might this be most appropriate in groundwater basins? And thinking about what are opportunities to increase recharge, especially due to disturbances from fires, or thinking about flood mitigation, just like we've been talking about today. So on the top right-hand side is an example of an initial suitability map or some work that's being done to integrate geology and soils layers, subsurface information that can really support or hinder recharge, We also have a student who's developing base flow indices for streams across the state of Arizona to help us also identify where water may be recharging in stream or be contributing, or where stream flow may be contributed from groundwater. So we're using a number of different kinds of data sources, including remote sensing, such as GRACE satellite, to start to chip away at this recharge side. And again, to really put all this information in a way that can be used for prioritization. We have a forest and natural management, natural environments team that's really thinking about management practices in our natural landscape. So thinking about wildfire, forest thinning, or burning rock dams and things kind of in that broad category, and starting to think about kind of similar to Eleonora's delta volume approach. What is that fractional change or change in volume that might be expected from these types of management strategies? For the natural environments, it is an area where we really need to think about trade-offs, that we're not trying to minimize all of our fluxes. We do want to protect our vegetation and our ecosystems. So really thinking about what are we trying to focus on and to reduce, and what are we trying to enhance? And the urban team, which this work is the most, I would say, relevant or perhaps of interest to this group, that's really focused on how urban management strategies can be used for either water capture or recharge in our cities across the state. I'm going to skip this slide because this is an initiated audience, and if you weren't before, you are by this meeting, or by the point in this meeting. So there are a few studies that we're doing that I just wanted to give a quick snapshot of. One of them is using empirical data, some of which from federal or government gauges, and some from monitoring that I've been conducting, to really help flesh out that figure to understand how does that runoff coefficient vary across urban and undeveloped watersheds and across watershed scales, and also incorporating additional metrics that include percent imperviousness or things related to vegetation. So for example, with Eleonora's tool, you can maybe fine tune or see the range of potential coefficients so that when you're selecting them, you may have different processes in those types of calculations. And we have a postdoc at ASU looking at recharge potential from dry wells and retention basins in Phoenix across the AMA. So with a number of different cities. She'll be presenting on this next week, but they've done calculations and also working with Geosystems Analysis, who's done a lot of work related to dry wells across the state, to really get some numbers of how much water do we think that we're recharging with these dry wells and with these retention basins. And so helping to, flesh out that cost benefit piece as well that Eleonora was mentioning. We also have a student using Hydrus to look at what is that interplay between water that's going, infiltrating, but is it making it past the root zone? How is that affected by soil type and various precipitation events? So again, we can support that fine tuning or help dial in assumptions for different prioritization efforts that you guys may be doing across the state. We also have a stakeholder engagement team, and Kristen Perthree, our graduate student, has been incredibly helpful in helping us develop an engagement plan and really work on hearing from people across the state. And you may have, a number of you may have heard from us. If you are interested and you have not, also please reach out and Kristen can help coordinate a meeting. We do have a flood control district workshop coming up in a couple of weeks that is very centered around this topic of today's meeting, and really trying to understand how can our project provide useful information for the flood control districts across the state trying to work on these types of efforts. I may skip over this in the name of time. I will just say from our stakeholder engagement, we've heard a lot of additional areas, suggested areas of focus. You know, a big emphasis on urban runoff and also integrate floodplain management. So to kind of using Eleonora's example of how do we use our water that's considered a nuisance or a risk to health or property, and how can we use it to support our water resources across the state. And these are some additional areas of focus that are less related to the urban environment, but just so you kind of see that it's a pretty fleshed out study where we're trying at this stage to have a very broad approach and think about the diverse range of interests across the state. And how are we doing all this? We're developing a lot of information. I just threw this slide here to show that not only are we developing a lot of technical information on this side, but that we're also thinking about how can we really filter or translate that information so that we can provide, you know, management, you know, in data-driven information to support data-driven decisions. Sorry, it's been a long day. And so, you know, not just we're doing a bunch of work and generating a lot of data, but thinking about how can that data become information. And I know I just covered a lot. I really broke my rule of 1 slide per minute. Again, this was a teaser, and happy to talk more.